Okay, here you go. So, what we're going to do, talking about possible mechanism of this one. So, this is nitrochloroperimidine, the first one. What is this? Nitrochloroperimidine. Uh, what I am going to show you here is what does this do. This chlorine going to leave. How going to leave? That's what I'm going to show you. This chlorine going to leave by this amine. This amines. So if we just focus on these two, you have this chlorine, this one, and this chlorine going to leave by this nucleophile like that. That's what's going to happen. Now, how this is going to leave? You have triethylamine, and you do have reflux, 33% its yield in ethanol. Only reflux. What we did? Only reflux. So with reflux, what happened? What happened with reflux? That's what I'm going to show you. So here to here, you have 2R here. You can set methyl group, 1 ethyl carbonyl here. N is plus because nitrogen is forming 3 bond with hydrogen, 1 here with carbon. You can walk around but here carbonyl and 2 methyl. Chlorine is 1 negative counterine of this ammonium salt. Triethylamine ethanol reflux 33 degree. This is yield 33%. What you got is just here this amine form a bond with this pyrimidine. Here was a chlorine, and now there is no chlorine. But what is this amine? And you have next to these 2R, then carbonyl, and you have ethyl group. Whole reaction is like that. So this is a whole reaction from here to here. Here to here. Now if we focus from just this one, what happened here? You have again ethyl group. This R, another R, this is a methyl, 60 degree centigrade degree temperature, yield sodium dithionite, Na2:O4. We used 2 molar sodium hydroxide, and this cyclized. How cyclized? This was converted into amine by the reduction that effect on this carbonyl, and a cyclizes here, and we do have double bond here. These are just a methyl. So that's what we have right now here. If we just enlarge this one, so what happened from here to here is just this nitrogen form with bond with the nucleophile. Now I do have another conditions here. If I use see, this is butanol, acetic acid, water, 3 solvent, 1 butanol, alcohol, acetic acid you put in your food, water 5 to 3. Oxygen 60 degree centigrade 6 hours, and this is a yield. What we got was just a carbonyl here, and this is a methyl group we have used here. So we can talk about this is SN aromatic addition elimination mechanism. What kind of mechanism is this one? This is SN aromatic mechanism. Is what kind of mechanism? Is SN aromatic, is SN aromatic mechanism. Okay, and SN aromatic mechanism. You might be asked about delocalization of the negative charge on nitro. This is nitro again. You have a double bond here, another double bond here because nitrogen forms 3 bond. This has NH2. You can sit here NH. On the top is carbon oxygen, you have nitro chlorine, and this is the same reagent which we use. Nitrogen has 4 bond plus charge, chlorine negative, or carbon oxygen. You have ethyl group, triethylamine ethanol. Just this NH2 form a bond here, chlorine with this carbon, chlorine does leave, and what will you have here? is just NH forming a bond with this carbon double bond. Everything two are on the, you can put on the top. These two are on the top, this carbonyl on the bottom, and you have one ethyl group. Now, what is the role of triethylamine? Is a one nitrogen and one ethyl. You can put another ethyl like that, another ethyl like that. Nitrogen going to do what? Now, what did you think nitrogen going to do? Nitrogen have a lone pair. It has 5 electrons outside an outermost shell. 3 it is using, another 2 left. That picks up 1 proton, and this nitrogen will take this electron, and you won't see plus charge now is NH2. Carbonyl, ethyl, and triethylamine will pick up 1 proton. Now it has 4 bonds. It will be plus charge. Chlorine will be counterion. What is the mechanism here? How does this happen? That's what I'm going to show you now. What is the mechanism here? So if you see, just focus on this step. What do you see in front of you? This is a nitro group. It has one oxygen and another oxygen, forming a double bond here. So you have nitrogen oxygen double bond and single bond with this carbon. And other oxygen is forming a single bond. That's why I have put negative charge here. So how many hydrogen oxygen you have? 2. And nitrogen, how many bonds forming? 1, 2, 2, 4. That's why I have put a plus charge here. Now these are the 5 electrons here. If you walk here, nitrogen double bond NH2 NH, you see you put in nitrogen, you break these lines. You can break from here as well. And this is oxygen, and here it's a separate molecules. Means how I'm drawing this, I'm just telling you. So this is amine, form a bond here, ketone, ethyl to methyl here, and these electrons go towards, it goes from here, form a double bond here, goes on one side like there, and then when it go on one side, form a double bond, it will be still plus charge, but these electrons come back, and this bond can come back again, and it will kick the chlorine. That's what you're going to see here. This is a negative charge, can form a double bond here, and then can push towards this. One of the oxygen electron can come back again. Plus charge you will only put if you have 4 bonds. How many? If you have 4 bonds, you will put plus charge. And if I have 3 bond with the nitrogen, I'm now going to put plus charge. These electrons come here, double bond come here. It will be single bond. Now double bond will be here, and it will kick the chlorine like that. It can kick chlorine one way. Now what you have next to this? 2-methyl and carbonyl and ethyl. What do you think is going to happen after that? Now these are the 3 molecules. This is just a nitro, and this is just ketone. What is next? I'm going to show you what is next. Reaction of ketone with amine. This is the whole reaction which I'm going to show you. Reaction of ketone with amine. Whole reaction scheme. I'm going to show you clearly what's going on here in the first step. If you focus on this step, what is here? What did you think what is here? You are using sodium dithionite, a reducing agent Na2H2O4, 2 molar sodium hydroxide. You have a nitro group here, you have oxygen here, you have carbonyl here, NH. You draw the straight line, you have a double bond here, nitrogen, you walk through NH2, keep a little separate, you draw right here double bond, and NHC, you draw this on top, whatever, oxygen down, 902. This is your substituted, 5 substituted nitropyrimidine, and you used what? Sodium dithionite and sodium hydroxide. What you got? Reduced this nitro to amine. And when you have amine have a lone pair. Is no plus charge because it's forming 3 bonds, but those lone pair form a bond with carbon of the carbonyl. and these oxygen double bond carbon is break and oxygen gets negative charge. This is reversible. Now you have shown this one reaction reversible. How is this reversible? What happened here? Now you have O negative opening of this bond, and you would, when this bond open, there will be one hydrogen which you can show here. Next thing, this NH is this NH you still have. You have R here too. It's going to be methyl, both methyl, and you have ethyl group here, this one, and O is negative. This NH would be plus first, but this oxygen can pick up this proton, will form H, or either water can pick up this proton, it will be NH, no plus charge. After that, what can happen? This will protonate, and when this does protonate, how this is going to be removed? If you are saying amine is going to pick up proton, another proton, which we can show here. So what happened here? If one proton pick up, it will be NH just. What it will be? It will be just NH. And when it is just NH, what do you think then? If I just show you, if it is just NH, can it move further? If it does move further and oxygen picked up another proton, if oxygen form one bond, it will be have two lone pairs. Now oxygen forming two bond here, one hydrogen on here. And what happened here? You have a water, and this water now going to do what? This water going to pick up this proton, this oxygen going to pick up proton, and it will be water. It will be plus charge, and it can leave. If this comes here, water can leave. That's what I have shown here. So this is water leaving. What is this? So this is water leaving. How it is leaving? N double bond. If I show you the back structure, it was like that. So now water is leaving. Water was formed here, and when water does leave, you will have N double bond, and that proton can be picked up by water. Okay, now at this stage, what will you have? Water is removed, and you will have this one. Overall, if I summarize here, what you see, what do you see here? Nitro reduction, formation of amine. You have ketone bond attack of this amine on carbon, opening of this oxygen, O negative picking up proton, one proton left, protonation of this one, this nitrogen form a double bond, water leaves, and when it does a double bond, you have H will pick up water. Again, sodium diethyl reduces nitro to amino, NH, you have a carbonyl, formation of bond with carbonyl, formation of oxygen, enoletine, pick up water, you will be left with just NH. This will be OH. Protonation of water, this N will form a double bond like that. Water will leave, proton will be picked up by water, and you will have this one. Now an example mentioned below is taken from whatsoever. Now we can talk about a little bit about the reaction of aldehyde and ketone with amine. I have an aldehyde, and I ask to aldehyde, are you going to react with ketone? They say, okay, I will do that. And how do they do? Aldehyde and ketone react primary amine to form amines. They react. Aldehyde say, okay, I'm going to react. Now if you see an aldehyde like that, what is that going to do? Aldehyde going to react. What is going to do aldehyde? Aldehyde going to react. How this is going to react, you will see it. But aldehyde and ketone both will react with amine to form amines or skiff base. We say to the skiff base. This is benzaldehyde and this is aniline. You will see formation of nitrogen double bond with this one and this carbon, and you won't see the oxygen. So that's what you have, one aromatic, this thing, aniline part, and other one from the phenol, and just double bond. So what amine going to do? Just forming double bond with carbonyl. You're going to say oxygen, you need to go. Oxygen say, okay, I'm happy to go. I'm going to run. You make a double bond with my carbon, and carbon say, okay, I like you. Oh, nitrogen, come on. So what will you see? Two double bond. You can walk on this, stand here, open your eyes, and you will see just double bond. Another side, whatever was next to your aldehyde is here. Whatever was next to your amine is here. Now water is removed in this process because you don't see two hydrogen and you don't see oxygen. And amine is a compound. Now if I show you amine as a compound, what kind of compound is? An amine is a compound with a carbon nitrogen double bond. A nitrogen analog of an aldehyde or ketone. Either you have an aldehyde or you have a ketone. This is a nitrogen analog of aldehyde or ketone. So this one is of an aldehyde. It can be of ketone, but it is a carbon nitrogen double bond containing compound. A nitrogen analog, this is nitrogen. So this is a nitrogen analog of aldehyde or ketone. So what is this? A nitrogen analog of aldehyde or ketone. Okay. Nitrogen aldehyde of analog. What is this? This is nitrogen. Just trying to highlight. Okay. So what is this? This is amine is a compound with carbon nitrogen double bond. Now we move further. Mechanism of amine formation involves, what do you think, what does it involve? Nucleophilic addition. Nucleus loving addition. Who is going to love nucleophile? What do you think? So I'm saying the mechanism of amine formation involves nucleophilic addition of amine. Of what? Of amine. Amine say, I'm going to add, I love nucleus. Does it love nucleus? Why it does nucleus? Love nucleus. It has a lone pair. That's why it's rich in electron. They say, I'm amine, my name is amine, I'm going to love nucleophilic addition. So mechanism of amine formation, what's going to happen? Nucleophilic addition going to happen. And where it is going to happen? Towards carbonyl. Carbonyl of what? Aldehyde ketone. What's it going to form? Stable intermediate. What is that? Carbinolamine. Now we're going to see what is carbinolamine. This is carbanolamine. This is on one side is alcohol and other side it is amine. That's why it is called carbinolamine. What it is called? Carbinolamine. So if someone asks you what is carbinolamine, what will be your answer? Your answer will be carbinolamine are compound with an amine group and a hydroxyl group like that. So you have oxygen, two lone pair, and next is amine. And a hydroxy group attached to the same carbon. Carbinolamines are analogues to hemiacetal. We will talk about hemiacetal as well. What are they? They are analog of hemiacetal. Mechanism of carbonylamine formation. You have seen a carbonylamine. We are going to talk about how carbonylamine are formed. Carbonylamine formation begins with nucleophilic attack. Now, where the nucleophilic attack occurs, of course, you have a nucleophile which is amine here. That's going to attack on aldehyde or ketone on carbonyl carbon. The carbon which carbonyl carbon. This carbon is called carbonyl carbon. What is this called? This carbon? Carbonyl carbon. So carbonyl amine, which is a hydroxyl group and amine containing carbon. What is carbonyl amine? Are compound with an amino group and hydroxyl group attached to the same carbon. We say carbinol. What is a carb? Because they are attached to the same carbon. Who? Enol and amine. Carbinolamine are compounds. What are they? They are compounds. And what do they do with an amine? So they are compound with an amine group and a hydroxyl group attached to the same carbon. Now, how they are formed, we are going to talk about. Carbonylamine formation begin with nucleophilic attack. Nucleophilic attack on the carbonyl carbon. You have a carbonyl carbon where nucleophilic attack is going to happen. Water and its conjugate acid both play a role. Water and its conjugate acid. What will be the conjugate acid of water? Conjugate acid, what will be? Now, if you have a water and proton comes with this water form a hydronium ion. What is a hydronium ion? Is a conjugate acid of water. So water and conjugate acids both play an important role in the reaction. Now we're going to see how do they play important role. What is this? This is a reaction which I'm going to show you. Now you have an amine, lovely amine. This comes towards carbonyl carbon and say to carbonyl, you take your oxygen on yourself, and that's what it does. Oxygen takes all the electrons, 5 electrons. Oxygen now has 6 electrons and a 2 here forming a bond, sharing 2 here, total 8, octet complete. But what happened to this nitrogen? Nitrogen usually forms 3 bonds, but it has 4. It doesn't want it. It has used 1 electron more, so that's why n plus charge. You will see. We said the role of conjugate acid of water. This is the conjugate acid of water. What is this going to do? This oxygen going to pick up 1 proton. It will form OH. This is formation of carbonylamine. Now you have a OH as well, and water here going to take a proton from here. Here water gives a proton, and here water will take a proton. Now water, hydronium ion, salt, conjugate acid of water gave a proton. What you got? Water. And now here what is going to do? Water going to pick up this proton in next step. So first step is what? First step is this enolate formation. This oxygen or negative formation where conjugate acid of water H3O plus is going to give a proton to this oxygen. Lone pair oxygen going to move those hydronium water molecules, water conjugate acids, and you will see OH. Next step, this hydrogen will be picked up by water and you will have NH2. Protonated water as a Bronsted acid. This is protonated water. This is now acting as a Bronsted acid. Nucleophilic attack of the negatively charged oxygen of the intermediate. Now, negatively charged oxygen, this one. Nucleophilic attack, where does it act? On the protonated water. You have protonated water, and what happened here? The nucleophilic attack happened. Attack of what? This oxygen. What is the charge on oxygen? Negatively charged. Where attack happened? Attack happened on the hydrogen. What hydrogen? Hydrogen of protonated water. This is one step. The second step we mentioned is here. What you see here, now water is again coming and saying, talking to try protonated salt amine. Oh, amine, you have 4 bond, you know good. You usually like 3 bond, you have protonated now. You have plus charge now. I can give you a favor. Amine say, what favor you can give me? Tell me please. And water say quietly, oh amine, you know what I can do? I can take your proton, I give you my oxygen, and I will be hydronium. And you won't have this trouble, the plus charge. I mean, say, okay, you do that. And this is reversible reaction. All these reactions is reversible. I mean, they can come back. You form this O negative, or this can go back. You form this OH, this can go back. And this can go back as well. So you have OH, and now here you will see NH3O plus as well. This is called carbonylamine. Carbonylamine compound which have hydroxyl group. What do they have? Hydroxyl group and amine group attached to the same carbon, carbonylamine. Now here what happened in the second step? Water as a Bronsted base. In the beginning, water acts as a Bronsted acid. On the top, you see here. Here is this acting as a base, and what is this doing? Acting as a base. What does base do? Base will have a proton. Here it takes proton. Proton of what? Proton of this salt, and oxygen does take it. Water on the Bronsted acid, nucleophilic attack of the oxygen of the water on the proton of the positively charged amine. You have a amine positively charged, it does take the proton. And what happened? Water has a Bronsted base, nucleophilic attack of the oxygen of the water, and what does it do? In a proton of the positively charged amine, on a proton of positively charged amine. So that's what has happened. And you have got a carbonyl amine. So this was the process what happened here. This is what I have shown. Now we can talk about further electrophilic carbon atoms. What are they? What do you think? What are electrophilic carbon atoms? Electron loving carbon atoms. What are? They are electron loving carbon atoms. Do they really love? Of course, and that's why I'm going to show you electrophilic. What are they? Electrophilic carbon atom. Those carbon atom of aldehyde. So aldehyde have a carbon atom, have they? What do? They like electron. They're electron deficient. That's why we say electrophilic carbon atom. So amine can attack there. Can be target of. It will be target of what? If they love electron, they are electrophilic, they will be attack of something which have electron, and those species are called rich in electron nucleophile. So that attack will be nucleophilic attack. And who can do that? Amine can do that. Amine say, okay, I can do that. The end result of this reaction, what kind of compound it will be? What do you think? Is a compound with CO? Do you think so? CO double bond is replaced. This was CO double bond is replaced by what? It will be CN double bond. Now how this happen? This form a bond like that. It will be double bond here. Oxygen will be gone. We say to this CO double bond, skip base. What we will say? Skip base or amine. This is what happened. In the first step, water is removed, and in the second step, water will be used. It will be that step where proton will be removed from here. That step water will be used. When it is a enol O negative, at that place hydronium ion will be used and water will be formed. Mechanistically, the formation of amine involves two steps. These are the same thing. First, the amine nitrogen act as a nucleophile. This one acting as a nucleophile, attacking the carbonyl carbon. This is the carbonyl carbon where attack going to be. This is closely analog to hemiacetal. Now, when it will be O negative, this is closely analog to hemiacetal and hemiketal formation. If closely analog, we can see. Now, this is a amine forming a bond with carbon, and you will have O and OH. Closely related to hemiacetal and hemiketal. Hemi half is one OH. Now, OH we have formed. Now these nitrogen can form a double bond. This proton will be removed and this will be removed as well. We will see based on your knowledge of mechanism, acetal and ketal formation. You might expect the next step would be attacked by the second amine. Do you think so? To form a compound with carbon bound to two amine groups. Now where can amine attack? Don't think so. Two amine groups. No, that's not happen. The nitrogen version of ketal. You mean another, but it doesn't happen. Nitrogen version of ketal. Instead, what happened next is the nitrogen is deprotonated. That's what can happen. Nitrogen is deprotonated. It will remove another proton, and the electron from the NH. So you will have NH electron bond pushes the oxygen off the carbon. This oxygen will be pushing off the carbon, leaving with C nitrogen double bond. It will be C nitrogen double bond here. This is amine or skip base, and displacing the water. There will be water here. The same thing which we can see here. So base comes, deprotonate the water, pushes this bond to form a double bond. This leaves as a water. This will be protonated by the proton. Arrow wrong. Arrow should be from here to here. And you will have double bond. This is K-bus amine. The conversion of an amine back to an aldehyde or ketone is hydrolysis. So if you have amine and you are converting it back to the amine and aldehyde or ketone, this is the ketone, this is called hydrolysis. And mechanistically it is simply the reverse of amine formation. This is reverse, mean you have now amine. And hydrolysis mean now how you going to do hydrolysis? You have a water here. What can do water? Now water can form a bond with carbon, that's what it does. How it can form a bond with carbon? Carbon is electropositive, is electron deficient. It can allow a nucleophile to attack. Who is a nucleophile? Oxygen. Yes, so if it forms the bond with this carbon, what will you get? You will be OH plus charge. Base will pick a one proton, and what will you have? Now on the other side, this bond is rich in electron and can pick up one proton from water. And what will happen from hydronium, even acidic water, acid and base? What will happen? You will have a single bond here. That's what you have. When you have a single bond and will pick up another protons, you will have. So overall, what happened here? On one side, OH is forming a bond. Water is forming a bond. And base is picking up proton, is leaving as a OH. And other side, what is happening? This double bond is forming a bond with what? With Ha. What is Ha? Ha is a proton from skiff acid. Whatever is acidic species, protonium is a hydronium H3O plus. So two things happen. In reverse, you know, in the previous step, what we did see first skiff base, first conjugate acid of water, which was H3O plus attacked, but here first water and then conjugate acid on this double bond. Why the double bond is exposed to attack of H3O plus? Because it is rich in electron, it can pick a proton. And why this carbon is attacked by the oxygen of the water? Because carbon is electron deficient. That's why this is a reverse process. Now here this is irreversible, reverse of amine formation. What happened next? Of course, you will have O. It can form a double bond like that. All this can leave. How this can leave? No, if you have NRH or you have NH2, how this can leave? These electron, carbon, nitrogen electron. No, do you think so? If you see this scenario in the next reaction, you can do that. I mean, you have this one oxygen next to on one side, nitrogen on the top, oxygen on the bottom. And what did it do? What did you do? You can remove carbon, nitrogen, single bond. You can remove carbon, nitrogen, single bond in this situation. And this is amine, primary amine. Now what will be left? Ketone. Now overall, if we summarize this one, is the same thing. We're going to summarize this one. What do you see overall here on the top? This one picking up a proton here and forming a water. This one picking up proton, forming N, proton being removed by the base. You will see N. And this can form a double bond when this leaves as a water. So here base is pulling proton, on the top protonation. You getting amine. And when do you have amine? Two step here, and those two steps will take it back to the same thing. At carbon electron deficient, who is going to come form a bond here? Oxygen, oxygen of water. And who is going to form a bond here with the nitrogen? Who is going to form a bond with double bond? Source of electron H3O plus will form a double bond. And then if it does form like here and with a double bond, where will be that bond? That bond would be this one. It will be with what? No, NR, it will be with nitrogen, because those electrons, pi electron, going to move with towards nitrogen. So you will have now instead of Nr another hydrogen attached with nitrogen. So pi electron between carbon and nitrogen are broken from the carbon. They're moving towards nitrogen, picking up a proton. On the other side, you have carbon which is forming a bond with oxygen of the water and giving you OH by the pulling of the base. This OH now move up, forming a ketone, leaving the amine. You have this one reaction which is, you said it is a rotation, methyl group rotating this way. So you draw all the methyl, you draw arrow from up to down just like this side. Here, now you cross the bond here. Here you can cross or not. You don't need to cross, then cross this way. So you cross from here to here. Here you cross from here to the other side. And you use a butanol, acetic acid, water, two things. Alcohol, acetic acid, water. Ratio is 5 to 3, 60 degrees centigrade temperature, 6 hour, 83% yield. CsP2 and CsP3 rotation. CsP, this is sp3, this is sp2, CsP2 and 3 rotation, and CsP3 3 rotation. Now this is a 3 and 2, I can say. This is 2 and this is sp2 and 3, but this is sp3 and sp3 rotation. Now we can talk about how this rotates, but overall here this is a free radical mechanism. If you have one hydrogen removed by free radical, you have just one hydrogen left. Now here this free radical then form a bond with oxygen and OH forms. Now another free radical will be removed. This is removal of free radical, then H plus, again removal of free radical. Now you have just OH. At this stage double bond is formed, free radical move here. This hydrogen leaves as a free radical, leaves this one free radical and oxygen, that form a double bond. So here will be loss of free radical. The hydrogen of methylene group is more available. You are saying that this is for oxidation than the methyl group. This is methylene, they are more available than methyl group. Due to rapid rotation of the methyl group rotates, it avoids the oxidation. It doesn't come in a way which help in avoiding the oxidation. It does help in avoiding the oxidation because freely of what methyl group as shown. It has reported that there is a barrier of rotation across sp2 to sp3. So this is sp2 to sp3 is a barrier of rotation. That's what they are saying. There is a barrier of rotation across sp2 and sp3. The extraction of H atom, which is free radical atom from methylene group, forms ethyl radical. So if from here methylene group extraction, this is CH3, CHOH or CH2. If you remove one of them like that, it's going to be CH3, CH. So they said methylene group form ethyl radical. This is going to be ethyl radical. The oxidation of aryl ethanol. Now after that we got ethanol. If you oxidize, might be more rapid than ethane aryl group. If you have just ethane, if you don't remove this one radical, it will be just ethane. But ethyl radical is going to go into alcohol, is going to go towards aryl ethanol, might be more rapid than aryl group, as the rotation of CHO group is slower than CH2 group. Even CH2 group is rotating, CHO group is slower. Below is the reference. Now you are giving a reference, and here you have nitro, propane and aldehyde. You put a base here, aqueous potassium hydroxide, and this electron negative charge here form a bond with this carbon of the aldehyde. So one side you have 2 methyl nitro, this one, other side this is forming bond with carbon. So you just put a carbon, and the other side is R and OH. So on the top you will see put aldehyde, carbon, RC, and instead of O you will put OH. On the bottom the same thing, 1 2 nitro, and you convert it into ketone with sodium dichromate Na2Cl2O7. Palladium and carbon, hydrogen HCl you use, you will have ketone. What will you have? Ketone. N protonated salt amine N plus, because hydrogen is forming 3 bond here, 1 bond here, 4, and chlorine. So what you have now is, I'm going to show the mechanism. This one, do you see this one? What is this one? This one is, you know what is this one? This one is, what is this one? Now I can show you. This is, you know, acidic proton, form a bond with this aldehyde. Oxygen go on oxygen, electron go on oxygen. You will have O negative here. This O negative now ready to pick up proton from water, form OH. So O negative to OH, and you have these things. Okay. And what happened after that? What happened after that? When you have OH, of course, what is going to happen? When you have OH, that's fine. So here, this proton removed and it forms a double bond. So you put, this is reversible like that, K plus OH, K OH, aqueous. And when you form a double bond, it's like that, NH plus, these one negative and other side, these two are negative. Why? Because you form a double bond, this electron go up, now one of them come down, these electron form a bond with carbon, and you have O negative, that is converted into OH by the picking of proton from the water. I think we stop here. Okay.